Hello, and welcome to a little video about modeling linear inequalities. Before we get started, let's talk about the inequality symbols. The first one we have is greater than. In order to write that x is greater than 6, I'm going to write this symbol. The symbol is open towards x. X is the bigger thing. I know in middle school and elementary school, once upon a time, we were taught that it was like an alligator or a Pac-Man, right? It's eating the bigger thing. The bigger end is towards x, the open end. Now what this means is x can be bigger than 6, any number bigger than 6, like 6.1 until infinity. We also have x is greater than or equal to 6. That's that same symbol with that open end facing x, but with a line underneath. That means x can be 6 and anything larger than 6. We also have less than. When x is less than a number, we have the pointy end of the symbol towards x. X is less than 6 means that x can be any number smaller than 6, meaning like 5.99 to negative infinity. Similarly, we can have less than or equal to, same direction of the symbol, the pointy end towards x, but this time it's less than or equal to 6, which means it can be 6 and any number smaller than that to negative infinity. Okay, let's talk about this problem. Number 1, Adrian saved $200. He already spent $25. He plans to spend $5 on a Starbucks drink each week. Let's run an inequality that represents the number of Starbucks drinks he can buy. All right, so let's begin with the total. How much money does he have? $200. Whoops. Let's try that again. $200. Perfect. Next, we know that he already spent $25. So 25 exists. It can't change. That's gone. Those 25 are gone. And he plans to spend $5 on a Starbucks drink each week. And is plus $5 per Starbucks drink. So we have 5. And we're writing an inequality to represent the number of Starbucks drinks he can buy. Do we know how many Starbucks drinks he can buy? No. What do we always use to represent the number of something that we don't know? A variable. Let's say x. Since this is an inequality, we need to decide on our symbol. 200. That's the most Adrian can spend. That's how much he had before he spent a single penny. So 200 is greater. It's the biggest it can be. So I'm going to draw the symbol with the open end towards 200. Now, if Adrian wanted, could he spend all $200? Yes, he could. Let's put an or equal to. Letter B is asking us to solve the inequality. Let's do it. Our goal is to get x by itself. X is attached to 5, which is attached to 25. So let's get rid of 25 first. What should we do to each side to get rid of it? 25 is positive, so let's subtract. Okay. 200 minus 25 is 175. On the other side, 25 minus 25 cancel. That's 0. And all we're left with is 5x. We are still looking for x. We have one last step to do. What should we do to both sides to get x by itself? Well, 5x is 5 times x. What is the opposite of multiplying? Dividing. Let's do it. Let's divide both sides by 5. Why am I dividing both sides by 5? Well, because then on the right side, 5 divided by 5 is 1. And we are looking for 1x. On the left side, 175 divided by 5 is 35. So 35 is greater than or equal to x. Now, to me, that always looks funky. I like to turn it around to flip it with x being on my left. So if I'm flipping x and 35, the symbol flips too. So flip x and 35, flip symbol. Okay, that makes more sense to me. X is less than or equal to 35. Now, what does that mean to us? Well, X is the number of Starbucks drinks he can buy, which means he can buy 35 drinks or less. Let's write that down. He can buy 35 drinks or less. That is not how you spell or. Let's try that again. Fantastic. Let's do another one. Vivian wants to buy tons of Air Jordans. She worked all summer and saved $650. She already spent $145. She plans to spend $150 on a pair of shoes per month. Let's write an inequality that represents the number of Air Jordans she can buy. Now remember, when I ask you to represent something, that's our X. So let's keep that in mind. Number of Air Jordans she can buy is going to be our X. Okay. First thing that we know from the word problem is that she worked all summer and saved $650. Let's start with $650. She already spent $145. So $145 exists in our inequality. We can't change that. That's money already spent. Also, plus, she then plans to spend $150 on a pair of shoes per month. Shoes is our unknown. So, 150 X. Let's decide on our symbol. 650. That's the most she has. She can't spend more money than she has. So we need to make sure the symbol is open towards 650. It's greater than. Could she spend all $650 if she felt like it? Absolutely. So let's add in an or equal to. Next, let's solve the inequality. First, let's subtract 145 from both sides. We're doing that because 145 is positive. To undo a positive is the opposite of a positive is a negative, minus. 145 minus 145 is 0. Perfect. On the left, 650 minus 145 is 505. All that's remaining on the right side is 150x. Let's finish up by dividing both sides by 150, because 150, x is 150 times x. We undo multiplication with division. 150 divided by 150 is 1. We wanted 1x. Perfect. On the left, 505 divided by 150 is 3.37. First of all, it looks weird. Let's flip it. If I'm going to flip the x in the number, I have to flip the symbol. X is less than or equal to 3.37. Now let's interpret the word problem. Does it make sense if I say that she can buy 3.37 pairs of shoes or less? No, there's no such thing as 0.37 of a pair of shoes. So we have to think of it in terms of the problem. She can buy less than or equal to 3 pairs, 3 whole pairs. Let's write that down. She can buy 3 pairs or less. Again, she cannot buy 0.37 of a pair. So think of the answer in the context of the problem. Perfect. Let's just do some algebra with it and also graph these on number lines. One thing we need to remind ourselves, we learned this at the very beginning whenever you learned about inequality symbols in middle school, that when you multiply or divide both sides of an inequality by a negative number, you reverse the inequality symbol. The reason we do that is negatives are opposites. So if we make things opposite, we need to make the symbol opposite. Just like when I flipped things in this problem, I made them opposite. Well, I kept them the same, but I wrote them opposite. Let's just do some problems. Number 1, let's solve it and let's graph it. First, let's draw a line down our inequality symbol. 3 halves x is greater than 4. 3 halves. It's a fraction. What operation is a fraction? A fraction is division, so we're going to undo it by multiplying. What we're going to do is we're going to multiply it by the same fraction but flipped upside down. Now if you forgot why we did that, let me remind you. On the left side, when we multiply fractions, we multiply straight across. So for our answer, 2 times 3 is 6. 3 times 2 is 6. On the left side, on the right side, 4 times 2/3 is 8/3. We multiplied by a positive fraction, so our symbol stays the same. Let's see if we can reduce. On the left, 6 divided by 6 is 1, so we're just left with x. 8/3 doesn't change, but if you wanted to, of course, we could put this in our calculator. The way you would do it is you write 8 divided by 3, then you press your control button and then enter. You would get 2.67. So x is greater than or equal to 2.67. How do we graph this? Well, when we graphed on number lines back in middle school, this is how we did it. We drew a little dot on the number line and then we drew an arrow. Now let's decide on the dot we need to use. When we have a symbol that's greater than or less than, we use an open circle. When it's greater than or equal to and less than or equal to, we use the filled-in circle. X is just greater than 2.67. So let's draw a dot, an open circle, on where we think 2.67 is. The numbers that are greater than 2.67 are on the right side. So I'm going to draw an arrow to the right. Let's try number 2. Here's another fraction. This time it's a negative fraction. When it's a negative fraction, or rather when it's a negative anything, and we're multiplying or dividing, we have to undo it with another negative. And let me show you why. So first of all, 2/3 is a fraction. That means it's division, so let's multiply it to undo it by the fraction flipped upside down. And like I mentioned, we need to make sure this fraction's negative, and I'll prove to you why. Okay, on the left, a negative times a negative is a positive. Then let's multiply our fractions across the top. 3 times 2 is 6. 2 times 3 is 6. On the right side, 4 times negative 3/2 is negative 6. Since I multiplied by a negative, my symbol had to flip. On the left, 6/6 is 1, so I have that x is greater than or equal to negative 6. Since it's greater than or equal to, I'm going to put a filled-in circle on negative 6 and draw an arrow to the right. Number 3. Let's draw a line down the middle. We will in a second. There we go. All right, let's start by adding 7 to both sides. I'm doing this because negative 7 plus 7 is 0, and I'm trying to get x by itself, so I'm moving that 7 away. So now I have 6x is less than 12. Now I need to divide. Let's divide both sides by 6 because 6x is 6 times x. The opposite of multiplying is dividing. 6 divided by 6 is 1, so we're just left with x. On the other side, 12 divided by 6 is 2. Did we divide by a negative? We did not. The symbol stays the same. X is less than or equal to 2. We're going to draw a filled-in circle on 2. Less is left, so my arrow goes left. Number 4. Let's draw a line down the middle. Okay. First, let's subtract 5 from both sides. On the left, we have 13. On the right, we're just left with 3x. All we did was subtract, so our symbol stays the same. Now let's divide both sides by 3, because 3x is 3 times x. We undo it with division. 3 divided by 3 is 1, so we're left with x on the right. 13 divided by 3 is 13/3. We divided by a positive, our symbol stays the same. Now, like I said before, I like x on the left, so I'm going to flip x and the fraction, and if I'm going to flip both of those, I need to flip the symbol. Okay, x is greater than 13/3. Of course, we can put it in our calculator, and you would get x is greater than 4.3. Since it's just greater than, we're going to put an open circle on 4.3 and draw an arrow to the right. Number 5. Let's draw that line. We're going to start by subtracting 7 from both sides. 7 was positive. To undo it, we do a negative, which is subtracting. 7 minus 7 is 0, which is perfect. That's what we wanted. There we go. On the left, 10 minus 7 is 3, and we're left with negative 2x on the right. Symbol stays the same. Next, let's divide both sides by negative 2, because negative 2x is negative 2 times x. On the left, 3 divided by negative 2 is a negative 3/2. On the right, negative 2 divided by negative 2 is 1, so we're just left with x. Since we divided by a negative number, we must flip our symbol. So we have negative 3/2 is greater than x. Let's flip it. I'm going to move x on the left, the fraction on the right, and if I'm flipping both of those, I gotta flip my symbol. X is less than negative 3/2, which is actually negative 1.5. So let's put an open circle on negative 1.5. Less is left. All right, I think this is the last one. Let's draw a line down the middle. All right, since I like my x on the left, let's start by subtracting 12x from both sides. Okay. 5x minus 12x is negative 7x. I'm going to bring down the plus 4. 12x minus 12x is 0. I'm just left with negative 10. The symbol stays the same. Next, I'm going to subtract 4 from both sides to undo the addition. So I'm left with negative 7x is less than negative 14. And for our final step, let's divide both sides by negative 7 to undo negative 7 times x. We're left with x on the left and 2 on the right. Since we divided by a negative, our symbol flips. X is greater than 2. Let's put an open circle on 2. Whoops. Let's try that circle again. Come back. There we go. Greater is to the right, arrows to the right. All right. That was a lot of rights in a row. So that is our lesson about modeling linear inequalities. If you have any questions, please make sure to ask myself or whoever else is helping you out in math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!